weren't expecting me to talk about that, then you're probably in the wrong room. And also, if you're expecting to see Romeo Kinsler talking, he sends his apologies. He couldn't make it today, so I'm going to go through the talk. My name's Simon Laws. I'm from IBM, and I'm from the Hursley lab in Winchester in the UK, but I'm also a member of the Apache Software Foundation, although a very inactive member of the Apache Software Foundation at the moment, which I hopefully will change shortly because I'm just about to change jobs, so I hopefully have a bit more time for that kind of thing. And so I'm going to spend 40 minutes talking about running Flink as a Docker container locally, and I'll talk a bit about how to do that in the IBM Bluemix cloud as well. Now, the Flink development community have done all the hard work here, so they've already done all of the configuration to allow you to do to create the Docker images and run Docker containers. So I'm going to refer back to the Flink source repository and show you how to do that. So I guess the first thing is why are we talking about Docker? Why do we want to do this stuff? I'll say some things about what Docker is and how Flink integrates with it in a moment. But really, this is all about ease of use and lightweight, portable runtime. So today, we want to develop on our laptops. We want to push up to the clouds. We want to create clusters dynamically. So it's all about that good stuff. It's all about being able to deploy Flink without having to deploy a whole host of physical hardware and physical operating systems. So this is what I'm going to talk about. So let me get the pointer working. There we go. So I've got my trusty ThinkPad here, as I'm an IBMer, and it's running Windows 7. And because Docker, the technology we're going to talk about, will only run on Linux, so if you're a Windows user or a Mac user, you'll have to do what I'm doing. If you're a native Linux user, then you can probably forget the virtualization bit. But I'm a Windows user, so I'm running Oracle's Virtualbox. And on top of that, I'm running Ubuntu Trusty, so 14.04. And then inside of that, I'm running Docker. And then inside of Docker, I'm running, have some Flink images, which development community produced. And then I've got a Flink job manager and a Flink task manager. So if you're familiar with Flink, you'll know what those are. We'll come to those in a moment. And so this allows me to run a Flink cluster locally on my laptop. And to access this, I'm just SSHing in from Cygwin. And when I'm able to run this successfully in my laptop locally, I can then push this into the IBM Bluemix cloud, and I'll talk a bit about what that is in a moment, using some more command line tools called this Cloud Foundry client from the Ubuntu image. Okay. So let me just go through the basic technologies first and what they're going to do for us. So first of all, Docker. So the idea is that you can host applications in Docker images in a more lightweight way than you can if you were installing a full operating system on a machine. So if you're familiar with virtual machines, then there's a good comparison on the next slide here. So if you go to docker.com, what is Docker, then you'll see their picture of virtual machines here on the left, where you have a host operating system and a hypervisor, and then various guest operating systems doing whatever you want to do. So I'm assuming you're all familiar with virtual machines. Now, Docker takes a slightly different approach based on this idea of containers. So if you're a Linux user, you're probably familiar with containers, the LXC stuff, which is what Docker is built on top of. And effectively, what it allows you to do is host your application with its binaries and libraries, but exploit all of the operating system binaries and libraries without actually having to install the operating system separately. Okay, so it's a lightweight way of producing a runtime environment for your application. And you can go and install that simply on Linux, go into the Docker site, download it, install it, plenty of instructions. And the next thing is Bluemix. Now, if we install Docker on our laptops, we can go and do our Flink install, and I'll show you that in a moment. But then when you want to actually deploy this and provide it on an IP address that people can get to out there in the real world, you know, what do you do with it? Well, one of the things you could do with it is sticking up on IBM Bluemix, which is IBM's platform as a service cloud. And the reason I'm just talking about this today is because you can sign up for free. There's a free layer that kind of doesn't go away. You can use it. You get external IP addresses. And one of the new things in Bluemix recently is this IBM containers thing, which is basically Docker containers. So if you build an image on your laptop, you can push the image up to the cloud, create a container, and expose it out to the real world. And then people can access your running application, your running Flink cluster. So, I'm going backwards. That's not a good start, is it? So there's a picture of the sign-up page. Why did I put that? Oh, yes, because you can register for Bluemix there. And just to reiterate, there are various options if you sign up for this cloud thing, and we'll come to this in a moment, but you basically, there's academic programs, there's startup programs, and as I said, it's a free tier when you sign up, which you can basically start using, carry on using for free as long as you don't go over the whatever the free limits are. Right, so to Flink and Docker. So if you go to the GitHub page for Flink here, and you look under Flink contrib, there's a Docker Flink directory, okay? Now, you can't read that very well. I've got it on a web page. Let me just show you what that web page looks like. Which one is it? Ah, there we go. Right, so this is the GitHub web page that I was just showing on that slide. So it's got a couple of directories, a base and a Flink. These are image directories. We'll talk about those in a moment. And a build script and a README script. So the README here has instructions for how to install Docker. So from the docker.com site, install Docker Compose. I'll talk about Docker Compose in a moment. And also how to build the images and deploy Flink in a Docker container. Okay. So a lot of what I'm doing on the stage here just comes from these instructions. So that should be fairly straightforward to find. What I've done is I've basically installed Ubuntu in Virtualbox. So what I did for that is I downloaded Virtualbox from Oracle. So as I said before, if you're on Windows or OS X, you'll need to do that. You'll need to get Virtualbox, create a Linux virtual machine. I'm using Ubuntu, and then install Docker and install the Flink source. So the first thing I did was I went to virtualbox.org and got Virtualbox, and I've got that running on my laptop now. And Virtualbox allows me to run virtual machines. So I created a virtual machine from the Ubuntu install. So I went to releases ubuntu.com and got 1404, got that ISO, went to Virtualbox, installed that ISO as a virtual machine. And then the only interesting thing that I did really was setting up the port forwarding, which can be a bit tricky. So if I just, where's my Virtualbox setup? So this is my running Ubuntu virtual machine, and for those who haven't done this before, there's a port forwarding tab, and the ports that I've got forwarded are the ports that I know the Flink job manager, for those of you familiar with the Flink job manager, these are ports that the Flink job manager is going to use to provide the web interface for the job manager and the thing that kicks tasks off. Okay, so that's all I did, and I port forwarded port 22 because I'm using Sigwin to SSH into my my virtual machine. Okay, so that's pretty much the only interesting thing there. So the end result is that I've now got Linux running on my Windows box. I can SSH into it, and I can then install Docker, and Flink, okay? So following along, I basically went to that page on the GitHub site that I showed you previously, and I followed the instructions there to install Docker, okay, which is just an install onto the Linux operating system. And then I installed Flink by cloning the Git repo onto Ubuntu. And so after all of that setup stuff, it starts to get a bit more interesting. So here are the two directories that you saw from the GitHub repo. It comes with a base directory and a Flink directory, and we'll go and look at those in a moment on my system. And the base is a base Docker image, and we'll go and look at the files and talk a bit about what Docker images are. And the Flink is a Docker image that's based on that base image. And then we've got two other interesting files. We've got the build file, which allows you to build the Docker images, and a Docker compose configuration, which allows you to start and stop the Flink cluster. Okay, so just before I switch over and we go and look at that, this is kind of what we're going to do. Okay, so the source is the Flink source, which I got from Git, where there are some Docker files which describe what the configuration of the Docker images are. And Docker images are, if you like, they're the binary version of the application and the operating system that's going to be instantiated into a container at runtime. And I'll show you this in a second, so it becomes a bit clearer. So what we do is we take the source, we do a Docker build to create a Docker image, and those images are the binary shareable things. So if you're familiar with Docker, there's a Docker hub where you can go and pull down already created images, operating systems and applications, all sorts of stuff. And you can pull them down and run them with Docker. And when you want to run them, you do a Docker run and you create a Docker container. So this is their terminology. And then the Docker container is like any other operating system running on a real piece of hardware. So you can SSH into it, and you can obviously interact with the things that are running there, like web applications and all that kind of stuff. So the Docker container is the running instantiation of that Docker image. Okay. So let's just go and have a look at what the Docker files look like. So you probably can't read that, so let me just go to the real thing. Okay, so I'm SSH'd into my Ubuntu operating system that's running in Virtualbox. And I've CD'd change directory into the Flink contrib Docker Flink directory, which is where where the source is that came down from Git. So you can see there's the base and the Flink directories, and the build and the Docker compose YAML file. So let's just go and look at the base directory. And you'll see there's a Docker file there, which is the important file. If I just have a look at that, you'll see that it's a recipe to how to build an environment in which we're going to run Flink. So it starts with a stanza for getting 14.04 version of Ubuntu, and then runs various commands, installs Java, and installs SSH and various things. But if you're kind of familiar with Linux, that should be fairly familiar stuff in terms of how to get the environment set up, ready to run Flink. And if we go and look at the Flink directory, and look at the Docker file there, then you'll notice the first stanza is it's building on top of base. And so Docker is all about these layered images. You build one image on top of another, and that's how it's relatively straightforward to build quite complex configurations. And you'll see this is doing some more configuration and installing some Flink stuff and getting ready so that we can actually run Flink in our image. Okay, so I've already done that for the sake of time. And I can now look at some Docker commands. If I do Docker images, it tells me what images I've got installed locally on my machine, my virtual machine. And you'll see that I've already got the Flink image here and the base image installed. The Ubuntu image is a basic one that gets installed because base depends upon it, and this one, this registry thing here, is something I'll come to related to Bluemix in a moment. So we've already got them installed, and Docker, as it's installed on my laptop, has this local registry of images which you can populate from Docker Hub, or you can create your own images as we've been doing here. And so now they're installed, I can use Docker run to run the images as containers. Okay, so I've got a command here that I'm just going to copy because it's fairly long. Okay, so I'm going to run this Docker command, Docker run, as a daemon. I'm going to expose some ports to the outside world. I'm going to give it the name job manager, and then I'm going to give it a command, which is this config flink.shell and job manager. If you go and look in the that source code for the Flink image, it includes this config file, and that allows you to run job managers and task managers relatively easily. So, oh, let me just get rid of. I ran it previously. I'm just going to remove that one and start that again. Okay, so that's started that image as a container now. So if I do a Docker PS, which is like a Linux PS, if you like, you can see that it's got a container runner called Job Manager. Okay. Now, question. Yeah. So the question is about the exposed ports. So these are only exposed on my Linux virtual machine and on my laptop. So let me just go back to the presentation because I can talk to the picture. Oh, wrong one. So we talked about this image, and we're now running this guy. So this guy is running inside of Docker, which is running inside of Ubuntu. And that Docker container is going to expose the ports that were included on that command line. And then, because of the Virtualbox configuration that I showed you previously at the start, those ports from this container are then exposed out to Windows so that I can access them from a browser. Right, well, that's only required. So okay, so there's a slight difference between the -p and the expose commands in Docker, because that 6123 is what the task manager is going to communicate with the job manager, and it only needs to see it in the context of Docker. So the -p allows you to expose ports outside of the container to the outside world, but the expose is between containers. So it's yes, a slight detail. So we've run that container now, just the job manager. But if I go to my browser, I should have, if I can refresh this. So I can go to my local URL that I exposed from my virtual machine and now run my dashboard. But of course, I've got no task managers running, so I've got no processing slots on my machine at the moment. And just for fun, I can log into that running executable before I start the task manager, just to show you what it looks like. There's a Docker exec command. While this Docker image has got SSH in it, there's a Docker exec command in the latest versions of Docker that allows you just to get straight into the image, into the container interactively. If I can remember the... Okay, so I can't read that. Right, so I'm now into the image, into the container where I'm running Flink, which is sitting inside of Docker, which is sitting inside of Ubuntu, which is sitting inside of Virtualbox. So you kind of get the idea. So it's just like a real operating system. I can move around the file system. I can see what's running, etc., etc. So for development of applications inside of specific operating systems, it's a very convenient approach because it lets you provision pretty much any version of any operating system. You can then run Docker, you can have those Docker scripts configured to install your application, run tests, close down, or ship the image off, and run it in production. Very convenient for doing all of that kind of DevOps kind of stuff. Right, so let me just quit out of here. And now I'll just go and start the task manager. Now this uses the same image name. Just go back to here. I'll try and copy it. Right. Right, so this time I'm doing a Docker run again with the same image, so Flink, but I'm linking. So I can't see the button to submit that stuff, so maybe we could try that. Let's try the word count. So I don't know how many people have tried the Flink example. There's quite a few examples you can try. Word count is probably one of the simplest ones. So this word count is going to run inside my Flink inside of my Docker container, and what I'm going to do is I've got some parameters here that allow me to do a word count inside of the, just scroll across so you can see that. So what I'm going to do is I'm going to read the readme.txt, going to run word count over the readme.txt and write the result out to temp. Okay, so we can run that. Oh, hang on. Let me do the upload. Why is that not? Right, just try that again. So this is just a standard Flink example, so nothing peculiar here. So this is the job that it's going to run, so it's going to do some mapping and some aggregation, so you're probably familiar with that. So I've submitted the job, and now that's running in my Flink cluster that's running inside my Docker container on my local machine. And you can see that it's already finished that job. Now if I go back to my command line here, now the job, you saw it writing out to temp result. Now I haven't got a distributed file system running in my Linux machines here, so I'm just going to log into the machine, the task manager machine, and have a look to see whether it produced some results. So I'll do this Docker exec thing again. There we go. Oh, so it's task manager 1, not task manager. There we go. And so, no, you can't see everything. Right, so you can see the contents of temp, and there's a result file there. So if I look in that, you can see the results of the word count. So we've shown that we can actually submit a job to our Flink cluster running inside Docker. So the next question is, well, assuming that we're happy with that, then I can probably click through this. Well, yeah. Oh, actually, there's something I didn't mention. To actually build the images in the first place, if you look in the directory, remember we talked about the base and the Flink directory, and we looked at the Docker files. Well, there's that sh file, that shell script file. If you look inside of that, it's a very simple file. All it does is run Docker build on base and Flink. So it just wraps up those Docker commands for building the images. So that's what takes that Flink source, uses the Docker files, and builds the Docker images from which I've created the Docker containers. Okay, so you just basically run that shell script once you've got the source down from GitHub, and you're pretty much good to go. So there we go. So that's the, get the right slide. There we go. Right, and so I think, yeah, what was the problem? Oh, yeah, I had a problem when I did this. When I did this, I got the source, ran build. It didn't work with this weird system check auth token error. And basically what it turned out to be after a bit of investigation was that I had an old version of Docker. I'd done an apt-get Docker IO on my Ubuntu install rather than actually following the instructions on the Flink page. So follow the instructions on the Flink page, they did a good job. And once I did that, it worked. So we talked about the built images. We've talked about creating the containers. So those are the two commands that I used. What I skipped over was this linking command when I started the task manager. So we saw the running of the job manager and the fact that it's exposing these ports. And the reason now should be clear why I was exposing these ports, and that's because I had to get at those applications, the ports from the browser. So that's why I'm exposing those ports, 1881. That's what I used to just run that example. And we were just talking about this expose port, because that's just exposing that port to this guy. And when I ran the task manager, we included this link. And link is a Docker parameter which tells Docker to inject some information about this container into this container. And effectively what it does two things. It injects an entry into the host file in this container with the IP address of this host. And it also creates some environment variables. And if you go and look inside of the Flink config, you'll see how those environment variables are used. In fact, we could just go and do that for fun. So if we go and look in Flink conf, I think it is, yeah, in the usual Flink conf YAML. So you're probably familiar with the Flink conf. So this is nothing to do with Docker. This is just the Flink runtime configuration. And you'll see there's a %job manager in this particular configuration. And that environment variable gets set up because I've called the job manager container job manager. So when I do that link to job manager, it sets up an environment variable called job manager, and that environment variable has the IP address of the job manager container in it. Okay, so that's how I get around having the task manager talk to the job manager without me having to do any complicated configuration. So I could have logged into the task manager container, configured the Flink config file, and then run the Flink runtime from there. But I didn't have to do it because because Docker supports those environment variables for me and the host changes. Okay. So let's go back to the charts. Okay. So the other thing I came across that was slightly odd was that when I ran this up on my configuration, then I got a strange exec format exception trying to run the this config Flink shell script. And the reason for that turned out to be that the shell script has got an Apache header on it, which Ubuntu's not expecting. It's expecting the first line to be /bin/bash, as you might expect. Now, from my Apache experience working on other projects, I know what we used to do come release time is run a script that put the Apache header on the top of any file that didn't have it. So maybe that's what happened here. So we'll have to feed that back in and see if we can get that fixed. But not a big deal. I just removed the header and it all ran okay. So then we get to the stage where you saw we got the thing up and running, and we had a task manager, and then we did an example. So I'll skip over that. Now, we come to the Docker Compose bit. so we've done all of this manual starting of containers from images, and Docker comes with this new thing called Docker Compose, which allows you to describe your set of collaborating Docker containers in one place and have them all start up manually. And so if you look in the, let me just go back up to here, the Flink developers have very kindly provided a Docker Compose image for us. And if you look inside of it, it's pretty much the same parameters as I provided on the command line to the Docker run commands that I used. So it's got all of that information encoded in it, and pretty much all I have to do is just do a, in fact, let me just do a Docker stop. Just let me just stop the other things. And then I'll give it a go. And the real advantage of this is scalability. So you can scale any of these tasks. So for example, the task manager, if you want more task managers, you can just scale that easily with a simple Docker command. So let me show you that briefly. That stops, right, okay. Docker Compose, -d. Right, so this is going to read that, and it's now created two things, and if I do a Docker PS again, you'll see we've got those two guys running. And if I do a, put my cursor back here, so I think it's Docker Compose, if I remember, scale, task manager. Let's say give it 3 task managers. And then there we go away. It goes away and creates more task managers. So now I've got 3 task managers connected to my job manager. So you can, all of that work I did running Docker runs, it's all done for you. You can scale it up and down, all that kind of good stuff. Makes it a lot easier to manage your Docker images. Right, so hopefully you've kind of got a rough idea of what Docker is and why we might want to use it to start and stop our Flink. Let me just go back into presentation mode. Now, I escaped out of it by accident. So now the question is once you've got these images all created, how do you deploy them to do something in the real world, so for other people to access? So an example of that is deploying them to the IBM Bluemix cloud, and the IBM Bluemix cloud has got Docker integration built in. So what we're going to do is look at how to use the Cloud Foundry client to deploy our images out to Bluemix. Now, I've already done that, so effectively what happens is that the Cloud Foundry piece is the technology that underlies Bluemix. And you basically just have to log in from the command line, you do your build stuff that we've already done, you tag your image with the name of the repo where you want your image to go, and then you just push it up, and then you can interact with it. So that there's a Cloud Foundry API plugin called it's the IBM container plugin. So you can use the cfic command, somewhat long-winded, in the same way as you would use the Docker command. So you can do cfic images and cfic run, but the images are actually, the containers are actually running up on Bluemix. So the advantage of that, though, of course, is that those containers are then accessible to people out in the real world. So let me just show you that before I run out of time. So if we look at the Bluemix dashboard, I'm logged into Bluemix here, and so this is out in the real world. If you go to bluemix.net, you can sign up and do this stuff, and you'll see that it's got You can create Cloud Foundry applications, which are kind of platform as a service applications. You can run virtual machines. So all of this VM stuff that I did with Ubuntu, I could do it up on Bluemix, although that's only just in beta. I can use the service API, so all of the storage stuff that's on Bluemix. But the thing I'm interested in is this containers API here. And I've already started the containers. I've already pushed the images up, and I've created 2 containers, and one of them is already running. And I can start this second. Ooh, that's not good. There you go, live demo. Decided it didn't want to start. So if I go to the dashboard, let me see here. So this is my, so my network's gone down, I think, or something. But basically, the idea is that that container is now on a public network at a public IP address. And with the free account, I can run 2 containers without charge, and I get 2 free public IP addresses. And so that IP address I can use, and so had this have worked, you can see that that IP address allows me to go to 8080, and I would see the Docker console as we'd seen locally. So the deployment story then is quite straightforward. Now, to get that to work, obviously you have to sign up to Bluemix. You have to get a couple of client applications, so this Cloud Foundry application, and then this IBM container plugin. But once you've got those, you can then push your images up. You can create images either through the web interface, or you can log in through the command line tool, as I did here. And when you log into the CFIC plugin, if you do CFIC login, as I did at the top there, it gives you the options you've got for interacting with Bluemix. So you can either interact with this CFIC strangeness, or you can set your environment variables and just use the Docker client to interact directly with Bluemix, as though you were interacting with your Docker images and containers locally. So that's pretty much what I did. So I pushed my images up to Docker in Bluemix, to the containers in Bluemix, and then so that was me pushing the images up. You can do CFIC images, and you can see the Flink image that I created was very similar to the Flink image locally. And then I created the containers, and you can either do that from the command line or from the UI. And I think I've got the commands here. So this was me doing it through the UI. There's a couple of steps where you can create how much memory you want to use and what the public IP address is. Or you can do it from the command line, and I think I've got the commands up here. Yeah, okay, so here are the commands. So very similar to the command I did locally. So it's CFIC run rather than Docker run. All the ports, the name, the image, it's got the Bluemix namespace in front of it, and then the command. And the only extra thing you have to do is then go into the UI and set the public IP address of that image, and you're up and running. And then the same thing for the task manager, which you should be somewhat familiar from me running it locally. And once you've done that, you've then got a Flink image, Flink cluster running on a public IP address that you can submit jobs to. Okay, so I think that's pretty much me out of time, possibly a minute for any questions, or just catch me afterwards. So one question down here at the back. Mm-hmm.
So just to tell about basics of our ecosystem, like we run kind of X machines of Hadoop cluster, and we run Flink and Spark as applications on Yarn, right?
Mm-hmm.
And yeah, just to note, like there are no library conflicts and all between Hadoop or Spark or Hadoop or Flink. So in this kind of situation, where resources are also properly managed by Yarn, how beneficial is it to migrate to Docker or some other container management?
It's just the ease of use, the lightweight deployment. So if you want to grow your cluster or shrink your cluster, or indeed replicate your cluster for development, it just makes that kind of stuff a lot easier. So you don't have to stand up physical machines and physical operating systems for development, test, and then deployment. You can do it all through Docker images, and of course it's easy to then to share those images with other people and create images at lots of different versions for testing purposes.
We can still do that with Puppet or Chef, right?
Sorry?
We can still do the same thing with Puppet or Chef.
Yeah, absolutely, yeah.
So it's like just deployment, is it?
Well, the Chef is more of a, an orchestration piece, so they're kind of different things, but that could be part of the picture. So I think we're probably out of time. So I'll hang around afterwards. So if you want to come and chat, feel free to do so. But thanks a lot for listening. Hopefully that was interesting. Enjoy the rest of the conference.